With all the recent buzz about K2-18b, that possibility of life,
Yeah.
it just brings up that really big question again, doesn't
He
it?
absolutely does. Are we alone?
Yeah. And the thrill you get thinking, maybe there's something. It slams right into this puzzle that scientists have been wrestling with for decades now.
Right, because finding even simple life would be incredible, but it sort of sharpens the focus on, well, if life can start, why haven't we heard from anyone else, given how huge the universe is and how old?
Exactly. That's what we're diving into today, Fermi's Paradox. And listeners, this exploration stems from an article you brought to our attention. Why haven't we come in contact with aliens? Fermi's Paradox explained. That's our launching point.
Mhm.
Our mission really is to unpack this paradox, look at some of the explanations people have come up with, and just try to get why it's still such a head-scratcher. I mean, the Milky Way alone,
Yeah.
billions of years old, hundreds of billions of stars.
Yeah.
The number of potential places for life is just mind-boggling.
It really is. Jason Wright, who directs the Extraterrestrial Intelligence Center at Penn State, he makes that exact point. Statistically, you'd think the universe should be buzzing with life.
Right.
And it all kind of crystallized back in 1950. Enrico Fermi, having lunch with guys like Edward Teller, just throws out this simple question, where is everybody? And boom, that's the paradox named after him.
It's that contrast, isn't it?
Yeah.
The numbers say, yes, aliens, billions and billions of chances.
Yeah.
But then reality is, well, what Wright calls the mystery of the great silence.
Yeah, the silence. We haven't picked up any signals, seen any visitors, nothing definitive at all.
It's quiet out there.
Very quiet. And, it's not for lack of trying. We have projects like SETI actively listening. The article mentions this 2015 book that listed, over 75 potential solutions to the paradox.
75. Wow.
Yeah, and Wright thinks there are probably even more now. It's a lot to sort through when you're asking that big question, where is everybody?
Okay, so let's try and break some of these down. The article starts with maybe the simplest answer, although maybe not the most exciting one for us.
Which is?
That maybe we really are it. The only intelligent life around.
The null hypothesis, yeah. It's possible. Maybe the jump from non-life to life, or from simple life to complex, intelligent, tool-using life, maybe that's just incredibly, incredibly rare. Much rarer than we think.
Right. The article points out that most scientists working in this area don't seem to lean that way.
That's right. It mentions that Nature Astronomy survey. Really interesting numbers there.
Tell me about it.
Okay, so they surveyed over 1,000 scientists, people in fields like astronomy, biology, and 87% thought basic alien life exists.
87. Okay.
And over 2/3, 67%, thought intelligent life is out there too.
Huh. So the we're alone idea, while possible, it's kind of a minority view among the experts looking into it.
Seems that way, yeah. Then you get into the slightly more out there ideas, like maybe they are here, but we just don't see them. Or maybe...
A cover-up.
Or a cover-up, yeah. That gets into more speculative territory for sure. Less scientific, perhaps.
Right. It's the kind of stuff your mind jumps to when the silence feels so weird.
Yeah.
But the article brings up a much more, practical problem, too.
Ah, yes. Interstellar travel.
It's just hard, isn't it?
Unbelievably hard. The distances, they're almost impossible to really wrap your head around. Proxima Centauri, the nearest star system. Our fastest probes would take, tens of thousands of years to get there?
Wow. Tens of thousands.
And the energy needed, the resources, even for robotic probes, let alone sending actual beings. It's astronomical. It's entirely plausible that this is just a fundamental barrier for pretty much everyone.
Yeah, that really grounds things. It's one thing for life to pop up, another thing entirely to travel between stars.
Yeah.
Okay, but then there's this other big category of ideas, the Great Filter. Let's try and understand that. What is it?
Okay, so the Great Filter concept is basically that there's some step, some hurdle in the development of life or civilization that's extremely difficult to get past. Almost impossible.
A hurdle.
And this filter could be behind us. Maybe the origin of life itself was the ridiculously hard part, or the jump to complex cells. Or maybe, and this is the more unsettling thought, maybe the filter is still ahead of us. Some challenge that advanced civilizations inevitably run into and, don't survive.
And the article gives some pretty grim examples of what that future filter could be, right?
It does. Things we can unfortunately relate to, like developing technology powerful enough to destroy ourselves, like nuclear weapons.
Right.
Or maybe running out of critical resources and causing societal collapse. Or fundamentally wrecking your own planet's climate, making it unlivable.
It does sound uncomfortably familiar, doesn't it?
Yeah.
Like potential paths we ourselves are navigating or trying not to navigate.
Exactly. Our own existential risks make those filter ideas feel very present. But Jason Wright adds an important caveat.
Okay.
He argues that for a filter to really explain the silence everywhere, it would have to be almost perfectly effective, like total extinction every single time a civilization hits it.
Why is that?
Because if even one civilization squeaked through, just one, over billions of years, they'd likely eventually develop interstellar capability, and we might see signs of them. So the filter needs to be incredibly, universally lethal.
That's a really sharp point. It raises the bar for what kind of universal catastrophe could keep the entire galaxy quiet. Okay, now, the article gets into some ideas it calls galaxy-brained, which sounds fun.
Huh, yeah. More imaginative possibilities.
Let's start with the zoo hypothesis. What's that about?
Okay, the zoo hypothesis suggests advanced aliens know we're here, they see us, but they're deliberately staying hidden, not interfering. Maybe they have some kind of galactic prime directive, like in Star Trek. They want to let us develop naturally without contamination from outside contact. So we're like exhibits in a cosmic zoo.
Wow. Okay, that's mind-bending. Observing us like animals. And then there's the planetarium hypothesis. That one sounds even stranger.
It takes it up a notch, definitely. The planetarium hypothesis suggests that maybe this whole view we have of an empty universe, maybe it's not real.
What? Like an illusion?
Exactly. Maybe some super advanced civilization is projecting it, creating a simulation or an illusion to make us think we're alone. Maybe for our own protection, maybe for some other reason we can't guess.
Whoa. That really pulls the rug out from under everything, doesn't it? Questioning reality itself. Okay, and the dark forest theory, that sounds darker.
It is. It comes from a Six and Lew's science fiction, The Three-Body Problem. It paints the universe not as empty, but as a dangerous place, like a dark forest filled with silent hunters.
Hunters.
Yeah. In this view, any civilization that makes noise, that reveals its location like sending out radio signals, is taking a huge risk because other, perhaps more advanced or predatory civilizations might detect them and decide to eliminate the potential threat.
So silence is survival.
Precisely. The great silence isn't because no one's there, it's because everyone who's smart enough to survive knows to stay quiet. It's a pretty chilling thought.
Yeah, no kidding. The silence of fear. The article also touches on transcendence. What's the idea there?
Transcendence suggests that maybe truly advanced civilizations don't stay physical in the way we understand it. They might evolve beyond needing planets or starships. Maybe they merge with AI, upload their consciousnesses, manipulate space-time. Essentially, they move into a different state of being, maybe virtual realities or higher dimensions, that makes gallivanting around the galaxy seem primitive or unnecessary.
Right.
They've kind of graduated from the physical universe.
Leveled up, basically.
Okay.
Now, Jason Wright, he brings up this critique of many of these solutions, calls it the monocultural fallacy. That sounds important.
It's a really crucial point, I think. He's saying that a lot of these explanations make a big assumption, that all alien civilizations everywhere forever would basically act the same way.
Oh, like they'd all want to explore. Or all hide. Or all transcend.
Exactly. Why assume that? Think about the diversity of cultures just here on Earth over just a few thousand years of recorded history. Now imagine different species evolving on different planets over billions of years. Why would they all follow the same path, have the same motivations, use the same technology?
Right. We're projecting our own ideas onto them.
We probably are. It's the monocultural fallacy, assuming one single culture or behavior pattern applies universally. The reality could be vastly more diverse and complex than we imagine.
That makes a lot of sense. It's easy to assume everyone thinks like us. Okay, finally, the article touches on something really practical. Just how hard it is for us to even detect anything.
Yeah, and Wright knows this well from his work with SETI. We're mostly listening for radio waves, maybe looking for lasers, technologies we understand, technologies we've only had for, what, a century or so?
Just a blink in cosmic time.
Right. What if advanced civilizations use communication methods we haven't even dreamed of? Neutrinos, gravitational waves, something completely unknown. Or maybe their signals just aren't aimed at us, or are too weak for us to pick up yet.
So the great silence might just be our inability to hear properly yet.
It's definitely a possibility. Right, Concealment considers seriously. Maybe the silence isn't quite as profound as it seems. Maybe we're just not tuned in correctly.
Okay, so wrapping this up, Fermi's Paradox.
Yeah.
The huge odds suggesting life should be common versus the stark silence we actually observe. Where is everybody?
Mm-hmm.
And the possible answers we've talked about, based on the article, they run the whole gamut. From we're simply alone, to space is just too big, to the really big philosophical ideas like the great filter.
Or the zoo hypothesis, the dark forest, the incredibly imaginative, sometimes unsettling possibilities.
And it's still wide open, isn't it? This isn't solved.
Yeah.
Your curiosity, listener, that sparked this deep dive, it's the same curiosity driving scientists and thinkers worldwide. It taps into something fundamental about our place in the cosmos.
It really does. That desire to know if we're unique or part of a much larger galactic community.
Absolutely. And Jason Wright's perspective, that the people actually doing the searching don't necessarily see the paradox as this, like, fatal problem.
Interesting, too.
So here's the final thought to maybe noodle on. Given how vast everything is and how limited our search tools still are, what's actually the more surprising possibility? Is it more surprising if we really are completely, totally alone in all that immensity? Or is it more surprising if the universe is actually teeming, full of life and civilizations, and we just haven't found them yet, haven't figured out how to see or hear them?
That's a great question to ponder.
Yeah. Think about the implications of either answer being true. It's pretty staggering either way.